Good morning. Goedemorgen. Ja. Goedemiddag in Dutch. Sobbecher in Farsi. Good morning. So happy to be here. So it's my first time in Hamburg. Yeah, super nice people. Great city. So kudos to all of you. So what's the plan for today? Today we are going to talk about image processing in the browser. Yeah, when it comes to image processing, it's a big word, but today we are gonna make it smaller, make it adapt to us as front-end developers so we can use it easily without any hassle. So first question, what is the most popular language technology out there? JavaScript, that's it. JavaScript is the most popular technology these days out there. Based on a Stack Overflow survey, which was released a couple of weeks ago. So JavaScript is on top. There is a QR. Also, our people will share the slides. No worries if you didn't get a chance to scan them. So JavaScript is the most popular technology these days. As you see, even in the text, it mentioned that 7% in Python. So it means that, yeah, there is a reason for that. I guess everybody knows. What is it? AI. So AI is there. That's why, yeah, Python is increasing. Fine. But JavaScript was on top always. So why don't we put AI and ML and all those technologies that Python people, developers are enjoying into our ecosystem? So me, a front-end developer, I always try to use technologies that I know, HTML, CSS. They ask me, can you put this image on the page? Of course I can. Can you set the width and height? Of course I can. So I can have the power of CSS3, HTML5, and add some filters, blur, and stuff. Yeah, and my image would be there. But can I detect object in it? No. It's not my superpower as a front-end developer. I always supposed to use a language besides CSS and HTML that we use, which is JavaScript. But JavaScript can do it on its own? Not. Because we should send a request to the server, the cloud server, take care of the object detection, and get back to us. But not anymore, because we have some superpowers in this case. Yeah, so this is the thing that we are going to tackle today, to see how we can do some face landmark detection. It's pure JavaScript in the browser with around 100 something FPS. So 100 frames per second, I'm detecting the face. Or I can have some pose detection for myself. Imagine how much I can do. I can do a lot, but for sure not dancing. As you see, I'm not a dancer. And also for my hands, so I can some hands pose detection. It's super cool because even as you see, I'm trying to, hit something. So you can have a canvas on top of that, maybe some virtual reality for yourself, build an app, and you can have exercise at home, like VR machines, Quest, and other VR machines out there. So in a 3D world for ourselves. So these are the models that are out there, and we are going to learn how to use them. So at the end of the day, the takeaway that I want all of you to have today is to bring your ideas as fast as possible to life. So at the end of the day, this is you have the enough courage to do that. That's the most important thing I want everybody to have. So are you ready? Are you ready? So a little bit about me. My name is Mo, passionate code wizard. I don't like these names, titles, but I like code, That's why I'm here. I have 15 years of experience in this industry. I was front-end tech lead, back-end developer, front-end developer, these days AI engineer. I don't mind. I just love to code whatever they ask me to do. I have a family of 4. We live in Netherlands. Yeah, not far from here. I play with my kids. Of course, I should. I love playing video games as well when they are sleeping. Yeah. And I love watching series. Any Ted Lasso fans? Yeah, I'm really jealous to the ones that haven't seen that. I'm really jealous because each episode of that for me is a therapy. So instead of paying therapy sessions, go and watch Ted Lasso. Believe me, it's worth it. Yeah, and I'm starving for sharing knowledge. So that's why I'm here. So because I do love to share knowledge with good people, amazing developers like you. So what's inside? First, we are going to go through a small introduction that what's going on, what is the plan, what is all the aspects that we need to carry on. And then I would define a problem, and together we will solve that problem by the knowledge that we learned. And then a little bit live coding. Real world apps, so what are the apps that has been designed based on the technology that we are going to learn? Built-in AI, a glimpse look at built-in AI as well, because it could be a part of image processing. And next steps that you guys can take with the courage that you will get. Introduction. Yeah, when I was 5 years old, JavaScript introduced. JavaScript introduced because we wanted to have some dynamic action, some logic in our application. And then WebGL introduced, 2011. WebGL was there, for instance, the apps like Google Maps and the stuff, it's using WebGL. WebGL is there to help us to render something in 2D, 3D, so make our life a little bit more visual and interactive. And then WebAssembly. It was a blast because WebAssembly was giving us the opportunity in our browsers, instead of using JavaScript, have near native performance. So it means that you would be near the CPU instead of using JavaScript in a sandbox, so on and so forth. So for instance, Figma is powering from WebAssembly. If you open developer tools, go to the network tab, you see that Figma or I don't know, Adobe Photoshop and other high performant application, all of them are using WebAssemblies. And then WebGPU introduced 2 years ago. WebGPU is like WebAssembly for CPU, for GPU. So GPUs, so we're out there, our applications weren't using them. We were using WebGPU. WebGPU was using GPUs as well, but in a tricky way, to be honest, because it was meant for rendering 2D and 3D. But WebGPU is there to handle something in parallel for us as well. So you can use the power of GPUs out there. For instance, Google Meets. Google Meets is using WebGPU. Why? Because as soon as you apply some background blur and stuff, so it should detect you and detach you from the background, apply some blur on top of your video, and it should be in a really good FPS. Otherwise, you can't, it wouldn't be a good experience for you. So WebGPU is there for performing ML models. So from 2016 till 2025, which we are, GPUs has evolved as well. For instance, in 2016, NVIDIA was 1080 CPUs. It had 2K CUDA cores in order to perform things in parallel. But right now, 5090 has 21K CUDA cores, plus AI cores, plus shader cores, plus ray tracing cores. So it means that our power has increased as well. So it's not like 2016 that WebAssembly was there, so WebAssembly was good enough for us. No, we want to do more than that. So it means that 10x more CUDA cores. And also keep in mind that everything has been evolved from technologies, hardware, and also JavaScript as well. JavaScript engine has evolved as well, because you remember that maybe at the beginning of introducing JavaScript and doing a lot of JavaScript, some websites were laggy, but not anymore because JavaScript engine optimized itself as well. And also recently, they introduced WebNN, Web Neural Network. So it means that instead of using CUDA cores, you can use NPUs from your CPU or GPU. NP neural processing units, that each company has their own names for them. So it means that you can more easily run neural network graphs and stuff in your browser. So stay tuned. So let's define our scope. As you know, we have a lot of scopes there. We have artificial intelligence, machine learning, and deep learning. Artificial intelligence like chatbots, Siri, ML like fraud detection, and DL, deep learning like face detection. So face recognition and detection. All of these are scopes that would be covered today as well, because the library that we are going to learn cover all these parts together. So no worries. So just imagine that all the things from ML, AI, and DL would be covered today. So machine learning models. Machine learning models accept just numbers, export numbers. You can train them as well. So for instance, for my image, so computer understand numbers, right? An array of RGBs. different points. We're going to send them to the model, and model output us the object that it detected. For instance, this is a person, this is a bag, this is a door. Easy. And also you can train them as well. So, and as you see, we are dealing with TensorFlow, the library that we are going to learn, CPU and GPU. All of them would be involved in this case. So there are a lot of machine learning frameworks out there. Keras, TensorFlow, Transformers, Onyx, PyTorch, ML5, JX. Some of them support JavaScript. For instance, Transformers has a version Transformers.js, and TensorFlow has TensorFlow.js. ML5.js was from the beginning in JS as well. So, but today we are going to focus on TensorFlow. But all the things that we are going to learn could be applied to others as well. So TensorFlow has been developed by Google, around 400K NPM downloads weekly, and 90K GitHub stars. And what are the platforms that you can use TensorFlow? It's better to say that what are the platforms that JavaScript can run. First, browsers. Second, Node.js backend. Third, you're free. Yeah, totally correct. Raspberry Pi. Raspberry Pi is the IoT. Fourth, your mobile phones. Yeah, and we have a fifth as well. Any guesses? Electron, yeah. Windows applications, desktop applications, Mac, everything which been written in Electron. So it means that you can use ML in all of these platforms, so everywhere almost. So TensorFlow supports a couple of backends. Backends, it means that how it interacts with JavaScript, it's better to say, and different browser adapters. First one is CPU, of course, JavaScript. We have Node.js in Node.js environments. We have WebGL in browsers. We have WASM, WebAssembly, of course, and we have WebGPU. So you can select either of them in order to have different performance for your TensorFlow application. So of course, CPU or JavaScript version is using CPU. WASM is using, again, CPU, but it's a little bit near to the CPU. That's why the performance is better. And then we have WebGL. WebGL uses GPU, but WebGL has a, WebGL, it's not designed to do things, computing things. It has been designed for rendering 2D and 3D, right? But the problem is, so in order to use WebGL API, you should do a lot of tricks. So duplicate your code, writing your logic into the shaders, later read them from pixels. It's so tricky to use WebGL. So that's why we go for WebGPU. WebGPU is somehow the direct interface in order to interact with your GPU. So all the cores, the CUDA cores and other cores would be available to you guys to interact faster. It's like comparing WebGPU and WebAssembly. So, for instance, a comparison, what was that? So if I want to compare different benchmarks, the CPU benchmark and WebGPU, you can see that the best time is around 30x faster. So the performance is totally different from CPU to WebGPU, even from WebGPU to WebGL, so you can feel the differences. And almost, I guess, all of our laptops these days, as a developers or others, middle-range laptops, all of them has at least some GPU cores. So, what is the problem? The problem started from one of my friends. He told me that I have a problem at home. I have security cameras, but a random guy show up at my doorstep, stay there with their dog, do their job, and they just leave. So this is the problem. So I thought to myself, yeah, I can use the models that I learn and I can prepare a demo for him to detect the guy and the dog, and maybe waiting for, I don't know, 10 seconds, which, he can modify that. After that, with the speaker, they can play something or warn him. Maybe after a couple of months or weeks, he made the habit. So the solution is, first of all, knowing the problem. We know the problem. Then define the goal. The goal is triggering an event to, notify the guy. Then we should investigate the models are out there. There are a lot of models out there, as I showed you. One of them is for face, the other one for body position, the other one for hand. Some of them are for detecting object. So you should compare all of them in terms of the performance, in terms of the frame per second, in terms of the size, RAM usage. So you should compare them with each other to make sure that which one suits your problem. And then gather requirements, for instance, the UI, the interface that your application is supposed to have. So now it becomes technical. We need access to the camera. Perfect. You can load the model. It's easy, I'm going to tell you. And then run detection logic. Detection logic for us is finding a person and a dog at the same time, and they are in the view for a couple of seconds, so it means that they are waiting there, and just move away. And then maybe after 5 seconds, 10 seconds, just trigger that something happened. So there are a couple of models, pre-made models for TensorFlow. Computer vision is one of them. Body position detection is one of them. Audio analysis or text classification. All of these could be models that you can use. But in our case, I guess computer vision is the one that we can easily use. And maybe audio analysis would be a case if you have a microphone there and you can hear something coming through the mic in order to trigger our application. So let's move on. So now it's time for live coding. You know the rule for live coding? Oh, exactly. We have gods of live out there. They don't let us to do live coding. So, and most of the time we fail. So if we do something right, you do clap. If I did something and it didn't work, you clap harder, right? Let's see. Okay, so from the top, here, what did I do? I just load TensorFlow CPU and Web GPU. So either of them would be available in the browser. So TensorFlow would detect one of them and just use it, right? In my case, it would be GPU, WebGL driver. So you can use as much as you want. So it automatically detects that. And also you can override it as well or force it to use Web GPU all the time or WebGL. So we need to import our model. So let me import it. So let me go to from first to, let me open package because I want you to know the package name as well. So we have TensorFlow, yeah, this one. TensorFlow models, CocoSSD. CocoSSD is a model from TensorFlow that was trained on the Coco data model of the Microsoft. So a lot of objects would be there in order to detect them. So I'm gonna import everything as Coco for myself. Coco maybe SSD. So this is my model. So what should I do? So this is a class that I just designed for myself to detect everything. It doesn't have anything special, just requesting for the my camera and these stuff. But the most important one is here. When you set up your model. So of course it should be asynchronous. So in order to get your model, so CocoSSD.load. That's it. Easily as this, it just load the model. So it means that a couple of megabytes download. So it download our model, and the model would be available after becoming, yeah, like this. So it's an asynchronous operation, of course. So we just loaded our model, easy. Ooh, the model. So way to go. Okay, so then with the model, we should start the prediction. So how can we get the prediction? So this, that model, which we have already saved, that detect. So as you see, it doesn't have any other functions as well. So detect, what does it accept? It accepts a couple of types, but in this case, I'm dealing with the video element, so I'm gonna put my video element. There are video elements. So then of course, it is asynchronous. Let me wait for that. Yeah, then my prediction would be ready. So 3 things: load the model, call the load the model import the model, load the model, and just detect everything with your video element. So let's see the result. Oh yeah, here, here, here. Yeah, this is my app. I just need to start detection. So as you see, yeah, it started detection, load the Coco SSD model, set up the camera. I have already access to my camera, so the camera is there. Model is ready, it has been loaded, and the camera is loaded as well. But right now we don't have any detection because it just detected me, right? I changed the code in a way that is people, dogs detected. That yeah, I'm gonna take a look at the predictions if there is a class of person or if there are a class of laptop, because we don't have dogs here, right? So I need one laptop. May I have your laptop for a moment? Yeah. Thanks. Yes, it's a dog. So let's see. Yeah, it just detects lots of stickers are here. So it is everything but laptop. But as you see, yeah, it just detected something for a moment with 72%, yeah, a person and 89% a laptop. But yeah, sometimes I try to be honest. Anybody else? Yeah, dude. Yeah, it's perfect. So let's see. It's live coding, right, guys? Yeah, 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 yeah. Yeah, so yeah, yeah, we should be, yeah, as you see, 63%. So you can change the code as you wish. So, it's all dependent on the, the camera, my camera and the stuff, and how long does it detect it, and how long does it take that I drew. Yeah, yeah, maybe, yeah, yeah. Yeah, better, yeah. Yeah, 99% laptop or a dog and 80 something percent a person. Why I'm 80 something percent? Thanks. Okay, so keep in mind, don't stick anything on your laptop. I'm kidding. Okay, nice. So let's move on. So that was the live coding. It wasn't that different. So what do we need? Okay. So let's recap. So the first one is accessing the camera. Yeah. Navigator, media devices, get user media, in this case, which I'm requesting accessing to my camera. Then loading a model, import directly from npm package that you have already installed, in this case Coco SSD, load the model into your RAM, and then start the detection by model that detect, model instance that detect, and then yeah, if is your logic has been triggered, so you can have your own logic, wait for 5 seconds or something to trigger it. So it was maybe one of the simplest things that we can do. Yeah, detect. So everything that we learned has been put in use in real life as well. One of them is, yeah, Lina Health's application. It uses on-device models, exactly the models that we learned today for physiotherapy and remote health and stuff, so you can keep track of your patients at home without asking them to come to your clinic. So you can have different position, different exercises. You can send them to your user, so they just need to open their camera, put it on the couch or something, and start exercising. So it detects everything for you and send the data to your doctor. Or the other one is Team Sports Z. Team Sports Z is using the same models in order to help beginner, athletes to have the data of professional ones. So how does the professionals, handle the ball or something? So it's gonna detect your behavior, compare it to that one, and give you a report. So you can improve yourself with yeah, these detections. And the other one is Derm Assist. It's an application for skin cancer and stuff. So whenever you take a picture, it does a lot of analysis on your device first and then send it to the server to check for quality or is it the right image or stuff. And the other topic that I wanted to cover is Web AI, because have you heard about Web AI, built-in Web AI? Yeah, built-in Web AI is in our browser as well. Let me give you a glimpse, because with Await language model that create, you can have your local LLM in your browser, a native API. So as you see, language model has been loaded on line 1 and on line 3. So I'm sending a prompt, where is Amsterdam? The answer to me was Amsterdam is the capital of and largest city in Netherlands. So easy, like prompting with your AI chatbot these days. So the tricky part is that it is a multi-model. So it means that it supports images and audios as well. So as you see, when I wanted to prompt my application, I gave two contents. The first one is an image. The second one is the text. So for instance, I asked, where is this image taken? So, and the answer for me was something that you can see at the bottom. It was my avatar, so it told me all the details about me. So it means that easily it performed a lot of analysis. And also there are some other APIs out there: translator, language detector, writer, rewriter, and summarizer. You can check all of them status on Chrome websites. Some of them has been shipped, some of them are in origin trial, and others, so you can keep track of them, but the language models are available right now. So next steps for you guys. Right now, what did we learn? Pre-trained models. We just used pre-trained models, but with TensorFlow.js, you can retrain existing models as well. For instance, as you noticed, I'm sure that it can detect remotes, but it doesn't detect this brand of water. You can train the model in order to detect these kind of models as well. For instance, yeah, there is an application for supermarket that they trained it on top of all the products that they have. So the workers there, in the morning, they just need to take a picture and it's gonna count all the shelves and the stuff, and the ones that are empty, it automatically order things. So it just made life easier for people at supermarkets. The other one is writing models from an empty canvas in JavaScript using tensors and others. And the only thing that we need is your creativity. Right now, you know what are the ML models. You can train a model with TensorFlow. You can make model with a low cost. Why? Because it is on the client machines. There is no cloud service that does that. I guess there is calculation for Google Meets. If they wanted to do, the blurring the background, they wanted to do that in the servers, each day cost $2 billion, something like that. So it's too much. So it's better everything happen at the client side without any cost. Low latency, so you are not dependent on a web server. And the privacy first, the most important one, because you don't send anything over the wire. Everything is at the clients. Your patients, your financial details would be kept at your machine. And of course, performance. You can detect face. You can give live feedbacks. You can perform text analysis. You can perform speech analysis. You can detect objects. All of them are ideas that you can use in order to make your next application live. If you want to learn more, TensorFlow.js website, Chrome developers website, super massive, lots of information. Kudos to Jason Mays, who helped me from Google, who helped me to prepare some of the content for this presentation. You can follow him with the Web AI on LinkedIn. Highly encourage everybody, because he's in the front of Web AI at Google. And thanks a lot. Any questions?
Beautiful.